In this lesson, we're going to learn how to add and subtract polynomials. And so the first thing we're going to talk about is adding polynomials. And in order to add polynomials, there's something that you're going to have to remember from a previous lesson, and that's the idea of like terms. So recall that two terms are like terms if they have the same variables and the corresponding variables are raised to the same power or the same exponent. So for example, the two expressions, the two terms I'm about to list are like terms. So for example, 3x to the fourth, comma, negative 8x to the fourth. So notice those two terms are like terms because they have the same variables. They both have the variable x, and the variable x both have the same corresponding exponent. They're both being raised to the fourth power. Okay, so notice here the same exponent. Okay, and then if we look at this one, so let's suppose we had negative 2xy to the fifth, comma, and let's say xy to the fifth. So notice these two terms are like terms because they both have the variable x and they both have the variable y, and the corresponding exponent, the corresponding powers for the x's are both the same. They're both 1s. And for the y's, they're both 5s. Okay, so same exponent for the variables, for the corresponding variables. Okay, now unlike terms, so these are unlike terms. So unlike terms. So in terms of unlike terms, these would be unlike terms. So let's suppose we had 8x squared, comma, and then the other term is 6x to the 8th power. So notice they both have the same variables, but the corresponding exponents are not the same. So this one's 2, this one's 8. So those are not like terms. You cannot add them, subtract them, combine them. Okay, cannot combine them. So exponents are not the same. Exponents are not equal. All right, we'll put that as exponents are not equal. All right, another example would be something like this. Let's suppose we had 1/3 y to the fifth power, and then let's say negative 5 x to the 8th power. All right, so those are not like terms. For one thing, the variables are not in both. So you see a y here, but you don't see a y here. You see an x here, but you don't see an x here. So they don't have the same variables. So we're going to say these are different variables. So these are not like terms because they have different variables. Okay? And then if we have, let's say, 3x and then the constant 9, so these are not like terms either because this has a variable, this does not. So I'm just going to put different variables as well. Okay? All right, so those are examples of like terms, and those are examples of unlike terms. So you got to know that in order to be able to add or subtract polynomials. All right, so let's go ahead and review a couple more things. So for example, okay, so recall that the distributive property is used to add or subtract like terms. So for example, if you look at this polynomial has 3 terms listed: 4x squared, a positive 8x squared, and a negative 3x squared. All of those are like terms. All those 3 terms are like terms because they have the same variable. They all have x, and all of the exponents of these x's are all being raised to the second power. Okay, so what I can do is I can use the distributive property to factor out an x squared. So in other words, I can write this as this: 4 plus 8 minus 3 times x squared. So that's what this equals. Now most students don't do that. When they're comfortable with combining like terms, they just in their mind know that they're going to add or subtract the coefficients. So the coefficient here is 4, the coefficient here is 8, the coefficient here is negative 3. So that's what you see: 4 plus 8 minus 3. And when I add those numbers that's inside the parentheses, 4 plus 8 is 12, and then 12 minus 3 is 9, so this becomes 9x squared. All right, but most students are when they understand this concept pretty well, they go from the question, the polynomial, to the actual answer. Okay, because all you're doing is adding or subtracting their coefficients. 4 plus 8 is 12. 12 minus 3 is 9. So you get 9x squared. Okay. Now I wanted to mention one other thing that many students kind of mess up here. I'm sorry, here. When they see 3x and 9, they want to say that if you add them, they want to say that is 12x. But you got to be careful. Those two terms are not like terms. So you're going to see that in some of the problems we're going to look at. As one more example, let's look at this one. So I want to add those two polynomials. I want to add, so notice that these are monomials. And remember, a monomial is considered polynomial. So you want to add these two polynomials here. Notice, though, that these are like terms. They both have x's and they both have y's, and the corresponding exponents are equal. The x's are being raised to the second power, and the y's are being raised to the third power. Most students, when they get that experience, know that all they have to do is add their coefficients. 4 plus 3 is 7. But we're going to go ahead and they'll just say, well, that's going to be 7x squared y cubed. So remember, when you combine like terms, the exponents stay the same. So notice x squared in the answer, x squared. Y cubed in the answer, y cubed. Okay? All right. So don't add the exponents. Don't say 2 plus 2 is 4, 3 plus 3 is 6. Don't do that. When you add or subtract polynomials, your exponents stay the same. X squared, y cubed, y cubed. Okay, all you're doing is adding or subtracting the coefficients. If you use a distributive property, though, you would say 4, the coefficient here is 4, plus 3. This is equal to 4 plus 3 times x squared, y cubed. So all I did was I factored out a x squared, y cubed, because that's what they had in common in those like terms. And so 4 plus 3 is 7, but we already knew that, right? Because all we did was just add or subtract their coefficients. Okay? All right. So the distributive property just allows us to add like terms. So that's basically why I'm using distributive property. But in reality, though, after you understand this, you really don't write it down. In your mind, you're thinking about it. You're saying, I have these variable expressions that are the same in both, so I'm just going to add their coefficients. 4 plus 3 is 7, and that's what you're doing. Okay? Okay, now, so with all that being said, what we now know is this: to add polynomials, you combine like terms, right? To add polynomials, you combine like terms. So let's look at this example. I'm going to start calling these. So the examples, the directions will say add. So right now we're adding, and then we're going to do a couple with subtracting. Okay. So let's go ahead and add. Number 1, let's say we had in this polynomial we have 3x to the 5th minus 7x cubed plus 2x minus 1 plus, and then 3x cubed minus 2x. Okay, so I have these two polynomials that I'm adding together. I have this polynomial that has 1, 2, 3, 4 terms, and I have this polynomial that has 2 terms. Okay, with experience, you're going to know what to do quickly. All right, but right now, what I'm going to do is I'm going to use the commutative and associative properties of equality. I'm going to use the commutative and associative properties to move things around in these expressions to put all like terms together. Okay, so basically you're going to say this. Now, remember, you can do this without doing all this work. It's very easy to see what the answer is when you're adding. At least these two. These two are easy to do. So notice that in terms of my variable, all I see is just the variable x. I have variable x's in all terms, but not all of them are like terms. Okay, for example, I see an x to the 5th, but I don't see any other x to the 5th, right? So 3x to the 5th I cannot combine with anything else. I'm going to put it by itself. So 3x to the 5th. Okay? Plus, Now let's do the x cubed. I see an x cubed here, and I see an x cubed here. Y'all agree? So I'm going to put those together. So I have negative 7x cubed plus 3x cubed. Okay? So I've taken care of this, this, and this. So that's this right here. Now my next one is x. So x here, and I see an x here. So I'm going to put those together. Plus 2x minus 2x. Okay? 2x minus 2x. And then, so that takes care of this and this. And then all I have left is this constant. So I'm just going to say plus a negative 1. All right? So that's what I have so far. Now let's go ahead and combine like terms that are within these parentheses. So I have 3x squared. Now, remember what's happening here. So these are like terms. So all you're going to do is add their coefficients. So a negative 7 plus 3, right? If you want to use the distributive property, you can. You can say plus negative 7 plus 3 times x cubed, just like that. And if you want to use the distributive property here, you can do the same thing. Plus 2 minus 2 times x, and then plus a negative 1. So if I go further with this, I have 3x squared. A negative 7 plus 3 is a negative 4. So I have minus 4x cubed. So this right here is this. 2 minus 2 is 0, right? So I'm going to write it down for right now. But I'm going to put this as 0x, and then plus a negative 1 means minus 1. You see that 0x? You don't have to put that in there. So you can say the answer is 3x squared minus 4x cubed minus 1. Okay? I'm sorry, that should be, that's 5, excuse me. That's 5 right here. 5. Okay, because of this 5 right here. I'm not sure why I put x squared. So that's 3x to the 5th minus 4x cubed minus 1, and there's your answer. Okay? But the point is this also, that as you practice with this, there's some of these steps you don't have to write down because it's actually in your mind. You're thinking about it when you combine like terms. Okay, so that's number 1. So 3x to the 5th, there are no other like terms, so you're going to rewrite it. 7x cubed, the x cubes, you have 2 of them. A negative 7 plus a positive 3 is a negative 4. A positive 2x plus a negative 2x is 0. See that here? You don't see an x in here. And then negative 1. All right, so that's number 1. Let's look at this one. This will be number 2. So number 2, we have a negative 2x squared plus 5x minus 1 plus a negative 2x squared plus x plus 3. Okay? All right, so I'm adding these two polynomials. To add polynomials, I'm going to combine like terms. So let's put the like terms together. So my like terms, I have an x squared and an x squared. So I'm going to put those together. Negative 2x squared plus a negative 2x squared. I'll see that? This and this. Then I'm going to put the x's together. 5x and x. So 5x plus x. And then my constants, plus a negative 1 plus 3. Okay? So all I did was put the x squared together, the like terms together, in parentheses. X squareds, the x's, and the constants. All right. Now, what's a negative 2x squared plus a negative 2x squared? What is that? All right, if you're having trouble with that, if you're having trouble thinking about it, use the distributive property. You have negative 2 plus a negative 2 times x squared, right? So I'm going to ask you again. What's a negative 2x squared and a negative 2x squared? What's a negative 2 plus a negative 2? It's a negative 4x squared, right? Okay, let's look at this one. Plus, what is 5x plus x? 5x plus x, remember that's a 1. So that's what, 6x? Again, if you're having a little trouble understanding how to add those, use the distributive property. So the coefficient here is 5 plus the coefficient here is implied to be a 1, right? And then times x. So you factor out an x. So 5 plus 1 times x is this right here. So 5 plus 1 is 6x, isn't it? So plus 6x. And then a negative 1 plus 3 is 2. So you can say plus 2. And there's your answer. Okay? And remember what's happening though. Okay? So all of this is in your mind. Think about it. Combine like terms. A negative 2x squared plus a negative 2x squared is a negative 4x squared. 5x plus x is 6x. A negative 1 plus 3 is 2. Okay? Not difficult at all, right? Very simple. It's not a difficult concept. Okay, let's look at this one. So this will be number 3. So number 3, let's suppose we had negative 4c cubed plus 3c squared minus 8c. So I have this polynomial, and I'm adding it to this polynomial. Let's say we had 12c cubed plus 8c squared, and then plus 7, let's say. Okay? Let's say we had that. All right, now, so let's go ahead and put all of our like terms together. So, and we're going to put this in descending order. Remember, we talked about descending order in a previous lesson. So from largest exponent to smallest. So I have a c cubed here, I have a c cubed here, right? So those two right here are like terms. This and this are like terms. So I'm going to put them together. Negative 4c cubed plus 12c cubed. Okay? Negative 4c cubed plus 12c cubed. Plus, then we put the c squared together. C squared and a c squared here. So plus 3c squared plus 8c squared, right? And then I have a c, but I don't have any other c's, right? C to the first power. This is a constant, so you got to be careful. Okay? So you're going to write this as plus a negative 8c by itself, and then plus the 7, just like this. All right. So in this parentheses, there are no like terms with this negative 8c, and there are no like terms with the 7. Okay, so let's think about this. What's a negative 4c cubed and a positive 12c cubed? So a negative 4 plus 12. So you're thinking about the distributive property. That's what you're thinking about. So you're thinking about writing this as negative 4 plus 12 times c cubed. So it's negative 4 plus 12. So the answer is 8c cubed, right? Okay, over here, same thing. What's 3c squared and 8c squared? So what's 3? You're adding their coefficients. What's 3 plus 8? So if you use a distributive property, you're thinking about this. 3 plus 8 times c squared. 3 plus 8 is what? 11. So 11c squared. And then all you have left are these, so just rewrite them. So you're going to say plus a negative 8c. Write it. Whenever you see plus a negative 8c like this, it's always preferable to write it as minus 8c, and then this is plus 7. So you're going to say minus 8c plus 7. And that's the answer. Okay, that's all you do. And then sometimes they'll have it written out in words, and by what I mean by that is this. Sometimes they'll say add 9y squared minus 6y plus 5 to 2, and then they'll say 8y plus 6. They may say something like that. Okay? So when they say it in words, basically what they're asking is, in terms of operation, they want to say, what is this plus this? All right? So this means, or they could say find the sum. All right? So add or find the sum. So this means 9y squared minus 6y plus 5 plus, and then 8y plus 6. All right? So let's combine like terms. Now, at this point, I think you're able to right away come up with the answer, right? So in terms of like terms, you have a y squared here, but there's no y squared in this polynomial. So far, I'm going to have 9y squared, right? And then your y's, I have a negative 6y here plus a positive 8y. So what's a negative 6 plus 8? A negative 6, you're adding their coefficients. Negative 6 plus 8 is 2, so you get 2y. And then 5 plus 6 is 11. And there's your answer. Okay? So that is, at this point, what we've done is talked about adding polynomials. All right? Adding polynomials. Okay, so now we're going to look at subtracting polynomials. To subtract one polynomial from another, recall the definition of subtraction. Remember, to subtract a number, we add its opposite. So if you see something like a subtract b, that means the same thing as saying a plus the opposite of b. Okay, A plus the opposite of B. So read this as opposite. Okay. To subtract a polynomial, we also do the same thing. We're also going to be adding its opposite. So before we actually look at some problems, let's kind of remind ourselves about what we mean by opposite. So the opposite of 6, and let me go ahead and put that here. So the opposite of 6, that word right here means this, the opposite of 6. So the opposite of 6 means negative 6. So the answer is negative 6. Okay, right here. The opposite of negative 8x, so remember opposite means this, look, the opposite of negative 8x, so the opposite of a negative 8x is a positive 8x, just like that, okay? And then here, we'll put that right here. So the opposite of, in parentheses, 4x plus 2, I need parentheses here because there are two terms. Just like I needed parentheses here because they had one term, it's always a good idea to put things in parentheses, especially if you have more than one term, because you're taking the opposite of every term. You're taking the opposite of every term. So you're saying the opposite of a negative 4x is a positive 4x, and the opposite of a positive 2 is a negative 2. Okay, forgot to put a negative right here. So the opposite of 4x is a negative 4x, and the opposite of a positive 2 is a negative 2. So this becomes negative 4x minus 2. Okay? All right. So that's going to help us with what we're about to do. Okay, so let's look at some examples. Okay, so as we do these problems, as we do these examples, we're going to remember this fact. So remember, we're adding the opposite. So to subtract two polynomials, you're going to notice that you're going to change the signs of the terms of the polynomial being subtracted, and then we're going to add. So we're going to add the opposite. Okay, so what this means is this. So you see I have subtraction. Now be careful, this is not addition, it's subtraction. So it's always a good idea. It's always a good idea to change this to addition. Change the subtraction to addition. Okay, so here's what we have. We have 6x minus 2 plus the opposite of all these terms. So when you add the opposite, you're basically changing the signs of those terms. So if you go back, when you're talking about the opposite of 6, you change the sign, right? The opposite of 6, negative 6. Negative 8x became 8x. 4x, negative 4x, positive 2, negative 2. All right, so you're just basically changing the signs. So the opposite of 4x is negative 4x, and the opposite of 5 is a negative 5. And so now we're adding two polynomials. So we went from subtracting two polynomials to adding two polynomials. Okay? All right, so let's go ahead and do that now. Okay, so 6x plus a negative 4x. So I'm putting those two terms together because they're like terms, right? And then my constants are like terms. I can say plus a negative 2 plus a negative 5, right? All right, so what is 6x plus a negative 4x? What is 6 plus a negative 4? The answer is 2x. Plus, what is a negative 2 plus a negative 5? The answer is negative 7. But don't write it like this. 2x plus a negative 7 is really 2x minus 7. So there's your answer. Okay, so that's the one we prefer. All right, so make sure you understand that. All right, number 2. In number 2, let's suppose we had 3x cubed plus 7x squared. So 3x cubed plus 7x squared minus 8x, and I'm subtracting this polynomial, which is, let's say, 3x cubed minus x squared plus 5. Okay? Let's say we had that. All right, so remember, you have two polynomials. This is the one you're subtracting, right? You're subtracting this. So notice when I change it to an addition, only the signs of the polynomial being subtracted change. This stayed the same. You see that? That's important. So you're subtracting this only. This is what you're subtracting. So you're going to change this to addition. You're going to change the signs of the polynomial following the subtraction symbol. So in this case, you're going to change this to addition, and you're going to change the signs of all of these terms. So think of it that way. You're going to change this to addition, and all these signs are going to change. So this stays the same. So I have 3x cubed plus 7x squared minus 8x plus, and then this becomes the opposite of 3x cubed is negative 3x cubed. The opposite of a negative x squared is a positive x squared. And the opposite of a positive 5 is a negative 5. Okay? Then let's combine like terms. So I'll put all the like terms together. So 3x cubed and a negative 3x cubed. So 3x cubed plus a negative 3x cubed, right? And then the x squared, so put the x squared together. So I'm going to say plus 7x squared plus x squared. And then notice that the rest are not like terms. So I'm going to just say plus the negative 8x plus the negative 5. Okay, when I combine like terms here and here, I have 3x cubed and a negative 3x cubed. 3 plus a negative 3 is 0. So this is 0x cubed, right? 0x cubed. Over here, 7x squared plus 1x squared is 8x squared. And then plus a negative 8x, so that's minus 8x. And then plus a negative 5, that's minus 5. Don't write the 0x cubed, so this should be your answer. Your answer should be 8x squared minus 8x minus 5. All right, so make sure you write it like that. All right, so don't put the 0x cubed because you need to know that 0x cubed is 0, so that term no longer appears. All right, so don't put it. All right, so that was number 2. Let's look at another one. So this will be number 3. So number 3. Okay, so number 3, we have this polynomial, and I'm subtracting from it this polynomial. All right, so I'm subtracting this polynomial. So I'm going to change this subtraction to addition. So I'm going to add the opposite of all these terms. All these terms, those signs are going to change when I rewrite it. That's important. So this stays the same. So I have, so this is going to equal a squared minus 3ab plus 8b squared. And I'm going to add the opposite of all these. So that's what that means, add the opposite. Negative 6a squared becomes a positive 6a squared. A negative 4ab becomes a positive 4ab. A positive 3b squared becomes a negative 3b squared. Okay? And now I'm going to add those two polynomials. So I'm going to put all the like terms together. So I have a squared and then another 6a squared. So a squared plus 6a squared. Okay? Now the ABs. So notice I have an AB here and I have an AB term here as well, right? I'm going to say plus a negative 3AB plus 4AB. Okay? And then the b squareds right here. So I'm going to say plus 8b squared plus a negative b squared, right? Okay, so this plus this. That's what you see here. Okay, what is 1? That's a 1 here. So what is 1a squared plus 6a squared? The answer is 7a squared. What is a negative 3ab plus 4ab? So what's negative 3 plus 4? That's 1, right? So we're going to say plus ab. Don't put the 1. It's implied to be a 1. What is 8b squared plus a negative 3b squared? So what's 8 and a negative 3? That's 5, right? So you're going to say plus 5b squared. And there's your answer. Okay, that's all you do. So it's not difficult at all, right? It's a very simple process, not difficult at all. All right, so let's look at this example. Sometimes you may see this. Sometimes you may see these words. So let's look at this idea. So sometimes you may see, number 4, you may see subtract. Subtract. Let's say we had 3x minus 8 from, subtract this polynomial from 8x plus 2. Okay? So subtract this from this. So when you see words like that, you got to remember something. So remember this. If I have this statement, subtract 4 from 10. What does that mean, subtract 4 from 10? If you were to write that out, what does that mean? Subtract 4 from 10. So subtract 4 from 10 means this. Means 10 minus 4. That's what that means. Subtract 4 from 10. Okay? Not 4 minus 10. Okay? So subtract 4 from 10 is 6, not negative 6. All right, so be careful. Remember the word subtraction. Subtract from. You gotta think about it in the correct order it's supposed to be in. All right, so subtraction is not commutative. So that's why you have to be careful. Subtract 4 from 10 means 10 minus 4. So when I have this, if you put it out, if you want to write it like this, which you should, what that means is this. So this means this minus this. So that means 8x plus 2 minus 3x minus 8. So subtract 3x minus 8 from 8x plus 2. So now I'm going to change this to addition. So I'm going to say 8x plus 2 plus the opposite of all these terms. The opposite of 3x is a negative 3x. The opposite of the negative 8 is a positive 8. And now we just combine like terms. So 8x plus a negative 3x, right? Plus, and then my constants, 2 plus 8. 2 plus 8. So 8x plus a negative 3x, 8 and a negative 3 is 5, so that's 5x. And then 2 plus 8 is 10. So there's your answer. All right, so remember that phrase, subtract a polynomial from another, you got to put this first. All right, so that's number 4. Let's look at one more. All right, let's suppose we had this one. So subtract this polynomial from this. It helps if you write out what that means. So that means this, subtract this. The order matters. When you talk about subtraction, the order matters. So that means 7y squared plus 9y minus 8, subtract, and then 5y squared plus 8y plus 2. All right, so that's what that means. That means subtract this from this. Okay? All right, now we're going to change this to an addition problem. All right, so when I change this to an addition problem, remember we're going to add the opposite. Add the opposite. So this polynomial stays the same, 7y squared plus 9y minus 8 plus, and then the opposite of each of those terms. So remember, just changing the signs. A positive 5y squared becomes a negative 5y squared. A positive 8y becomes a negative 8y. A positive 2 becomes a negative 2. All right? And then all it is just a matter of you combining like terms now. So to add two polynomials, you just combine like terms. To subtract, you change it to an addition problem, so you add the opposite. And now to add, you just combine like terms. Okay? So here's what we have. So let's put the y squareds together. So we have 7y squared plus a negative y squared, right? And then let's put the y's together. Then we have plus 9y plus a negative 8y, right? And now we have plus a negative 8 plus a negative 2. Negative 8 plus a negative 2. All right? So notice, like terms, you see that right here, correct? So we're adding. See this adding right here? We're adding these two terms, okay? And they're going to add that 2, and then we're adding these two terms right here, and then we're adding these two terms, negative 8 plus negative 2, okay? So what is, now remember to combine like terms, you're just adding their coefficients basically. So you're kind of using that distributive property. 7y squared plus a negative 5y squared, 7 plus a negative 5 is 2y squared. 9y and a negative 8y, 9 and negative 8 is 1. So just put it as plus y. So positive 1y, right? So just y, okay? And then negative 8 plus a negative 2 is a negative 10. And that's it. There's your answer. All right? So that is the lesson on, and let me get to the original. That is the lesson on adding and subtracting. So adding and subtracting polynomials. The one thing you got to remember is that when we talked about subtraction, you have to remember when you subtract two polynomials, you're going to change this to an addition problem. So you're going to add the opposite, and it's always the polynomial following the division. Following the subtraction symbol, you're going to change the signs of each of those terms. And then to add polynomials, remember, you are just combining like terms. Okay? All right, so that is the end of this lesson.